Module 4, Lesson 6 are talking about parallel and perpendicular lines and how to tell whether two lines are parallel or they're perpendicular or the two lines may just meet regular. So to figure out if two lines are parallel, they have to have the same slope, which makes sense because if I draw two lines like this, okay, they're parallel, they have the same incline. If the inclines are off by just a little bit, they're going to meet. Non-vertical perpendicular lines have the slopes that are negative reciprocals. For example, if one line has a slope of 1/2, slope line 1, the other one will have to have a slope of, we take the reciprocal and negate, -2/1. That'll be the slope of the second line. If I multiply these two values together, I'll get -1, which is why it says the product of their slopes is -1. There's a couple of different examples we're going to be looking at this. What happens if I know that line 1 goes through 2 points and line 2 goes through these 2 points? If I calculate their slopes immediately by the given information, I can tell whether these lines are parallel, perpendicular, or neither. We're going to use the slope formula. So let's look at line number 1. So I'm going to call that m sub 1, slope sub 1. So we're going to do 2, take away 1, the difference of the y's, 9, take away 3, so this will be 1/6 is the slope of the first line. Now let's take a look at the slope of the second line. Let's call that m sub 2. Okay, so 10, take away 9, 7, take away 1, so that would be 1/6. Oh, the slopes are the same, yay! So therefore, since the slopes are the same, the lines are parallel. Perfect. Okay, now let's take a look at B. Same deal. We are going to calculate both slopes. Line 1, m sub 1, 5 take away 2, 3 take away 1, so this will be 3/2. That's the slope of the first line. Now let's take a look at the slope of the second line. 7, take away 9, -1, take away -4. So 7 take away 9 is -2. And -1 plus 4 would be 3. Okay, so if I look at these, 3/2 and -2/3, well, they're negative reciprocals. So since the product of the slopes is -1, which it is because 3 times -2 is -6, and 2 times 3 is 6, so it'll be -1, -6/6. The lines are perpendicular. Ta-da! Yay! Okay, let's go on. Okay, so now, instead of just giving points on the lines, we're given the equations. So it would be really, really good to write each of the lines in slope-intercept form, and we can just read off the slopes. And bam, bada bing, we can figure out whether they're parallel, perpendicular, or neither. So let's do A. So we have two lines. Here's my first line that I just circled, and I'm going to solve for y in terms of x. So x minus 2y equals -10, and I'm going to bring the x over to the other side, so -2y is equal to -x, take away 10, and then I'm going to divide everything by -2. So y is equal to, now this looks funkadelic. I'm going to put a 1 in front of the x, so it's negative 1 divided by negative 2. So it's really a half x. Negative 10 divided by negative 2 is a positive 5. So the slope of line 1 is equal to 1/2. It doesn't look like a 1. So I'll erase it, and then we'll put a little 1 there so it looks better. Okay, so now let's look at the second line. Y is equal to negative 2x plus 5. Excellent. I don't have to do any work. I can just read the slope off of that. The slope is equal to negative 2. So if I multiply 1/2 times negative 2, I get negative 1. So the lines are perpendicular. Okay, so let's do the next one. Again, we're given two equations, and what we want to do is we want to solve for y in terms of x. So I'll get 3x, take away y, is equal to 6. So I'm going to bring, well, I can do this. I can bring the negative y over to the other side and then bring the 6 over here. So it's going to be y is equal to 3x, take away 6, or writing it like this is much better. So the slope of line 1 is just regular 3. Now let's take a look at this guy right here. So get 3y is equal to negative 1x. I'm just going to put a 1 in front of that, negative 1 in front of the x, and then just divide both sides by 3. So negative 1/3 x plus 1/3. Yay, my slope of line 2 is negative 1/3. And again, they're perpendicular, because if I multiply 3 times negative 1/3, I will get negative 1. So the lines are perpendicular. I'll write perpendicular symbol. There it is. That's the perpendicular symbol, because I'm getting lazy. Okay, next slide. All right, the next slide is, what about vertical and horizontal lines? We're always, after we introduce a concept, we like to kind of bring it back to these guys, because these guys are special cases. So what we're going to do is I'm going to take you through like a little bit of a process, because I want to find an equation of a line parallel to the line x equals 5 that passes through the point 3, 4. So I have these little cute steps here. So I'm going to graph the line x is equal to 5. So I have to go out 1, 2, 3, 4, 5 here, and x is always 5, so it's going to be a nice vertical line. So I'm going to just put. And if you hate the way I just did this, you can actually just do it as a table where x is always 5 and y can be anything, and you can graph those points. Okay. Now we're going to graph the given point 3, 4. 1, 2, 3, and up 4. 1, 2, 3, 4. There it is, the point 3, 4 in all its glory. Now we're going to draw a line through the point 3, 4, but parallel. So I want to include this parallel. I'm just going to draw a line right down like this because they're parallel. Ta-da! And now we're going to state the equation of the line I just drew. Well, this is another vertical line where x is always equal to 3. So the upshot of the deal, let me erase that a little bit here because it's not that great. So I'm going to just write a nice 3 here. There's the equation. Okay. The upshot of the deal here is if I want a parallel line through a point, I just have to choose the x value if I have an original line that has an x value associated with it. I think it's easier to see when you're doing it graphically. Let's do one more. Yeah, let's. Here we go. Now we're going to find the equation of a line perpendicular to the line x is equal to 5, and it passes through the point 3, 4. In the slide before, we wanted to find the equation of a line parallel to this line. So we're going to graph x equals 5, and this should be pretty easy. 2, 3, 4, 5, because I just graphed it. Okay. X is equal to 5. And then graph that given point, 3, 4, 1, 2, 3, 1, 2, 3, 4. There it is, again, in all its glory. Now we're going to draw a line through 3, 4, but perpendicular to the first line. So here I go. And this is kind of hard for some people to see. I remember when I was doing this with students before, I said, draw it perpendicular, and they couldn't quite see it. So hopefully you'll be able to see it when you do your work on this. And now we're going to state the equation of this line. Well, this line always has a y value of 4. So y is equal to 4 is the equation of the line. And notice how I pick the y value instead of the x value. So what I'm trying, I just have to make sure that I do all my graphs nice and straightforward so that I can kind of see what's going on. So now you will be able to do the homework in MyMathLab as well as the written assignment right after this lecture. And again, if you have any questions, ask your teacher.